Okay, we're covering Algebra 2, Lesson 2.5, and we're constructing the circumcenter or incenter of a triangle. So you need to understand what that is. And so what I want you to do is to be able to identify, and I'm sorry I wrote that twice, to identify I don't know what happened here. There was a glitch in the system. Identify the circumcenter. Let's just do it this way. The circumcenter, also known as the incenter of a triangle, all right? Circumcenter or incenter, it's called both things. And so this video is going to support, again, the Geometry IXL lesson M.6. So that's the two most important things there. Then, of course, you're going to take your notes in your notebook and explain how you could use it to solve a similar problem. And then you'll upload your notes to my student Dropbox. I will have the Dropbox for this set up this evening, so hold off till then and you can put it in. If for some reason you cannot get to my Dropbox, of course, your standby is to go ahead and send it to my email at joshua.warren@tusd1.org. Okay. So this is pretty short, but there's a lot to be said in between the lines on this. So this is taken from your IXL. This is what you typically see when you're doing construction. So again, you have the construction screen, got a place down here to click various things that you're going to use to change the picture. In this case, we want you to construct the circumcenter or incenter of a triangle. So it says here that CD line.
Are we supposed to be seeing the problem?
Can you not see this?
No.
Okay, so I'm going to have to stop and share the screen. So let's just do that, and let's minimize, share the screen, and we want to go to, okay. So since you had a trouble seeing that, let me just go back over here to, again, the beginning of it. So you're identifying the circumcenter or incenter of a triangle. This is going to support geometry lesson IXL M6. And then the rest of this information I told you, but you will be writing notes on this. It'll explain how you could solve the problem, a problem that is similar to it. And then you'll upload your notes to the Dropbox. Again, I will have the Dropbox open this evening, so you can put it in there, and a fallback, again, in case you can, is you can email it to me at my email address that shows here as joshua.warren@tusd.org. Okay, so again, this picture you're seeing here is an IXL picture. This comes from M4. And it says here that line CD, so when you see the line with the two arrows above the CD, that's telling you that this is a line. So I look for line CD. It's this line right here on the picture. And it says it's the bisector of angle C. Well, here's angle C. So what that means is that it split angle C into two angles that are congruent to each other. They're actually congruent. So I'm showing these two arcs as showing they're congruent. And AE is the bisector of angle A. So AE is this line here, and it's the bisector of angle A. So that means that angle A has been split up into two equal angles. they want to know what the incenter of triangle ABC is. So to understand what an incenter is, an incenter is referencing a central point within a triangle, okay, where the circle touches the sides of the triangle. And I actually drew one in here. I've got a picture that's pretty much the same as this one. And so here's the picture. And I took one of these compasses. So in this case, it was, where is my compass? There it is. So I took this compass, and now I'm freezing up. So let me unfreeze. Come on. Okay, so I took this compass and I went ahead and I marked the center of, I used that to come up with a circle that was in the middle. And what I found was the center of that circle was this point here. So the point is is the exact center of the circle, as far as I'm sorry, exact center of the triangle, because it's the center of the circle. And incenters, again, is of a triangle is the center of the inscribed circle, and that's the inscribed circle. It is equidistant from all three sides, and it is the intersection of the bisectors of each of the triangle's angles. So EA here is a bisector for angle A. Here it is. And CD is a bisector for angle C. And where they cross, they actually will call this, in this case, I think we called it B, C, D, E, F. I think this is F. And so you could mark that again. And so on this one here, I'll do the same thing. F is called the incenter. It's called the incenter. And so knowing that, it's, again, the center of the circle, which is formed by creating, bisectors. And so we bisected angle A and we bisected angle C. We drew lines through the where the bisection occurred. And in that center, that, again, that F is the incenter. So incenter, what is in the center of? It's in the center of the circle. If you think of it as the center of the triangle, you're going to say to yourself, well, the distance from B to F is a lot longer than the distance from F to A, and from the distance from C to F, and so on. But when you draw a circle in it, what they're really talking about is that there's a circle that touches the sides of the triangle, whose center is F, which also happens to be the intersection of the two angle bisectors that we put in here. And so the distance from F to this side, from F to this side, from F to this side, and from F to this side, these 4 points, these are all equidistant because they're on the edge of the circle, and the center of the circle is F. Okay, so you can always draw an incenter by taking a compass, putting it in here, drawing around the edge, and even though I'm a little bit off, you can see it touches here, here, and here. It touches the sides of the triangle, so that is an authentic circle that forms the incenter, which is the center of the circle, and it is what they're looking for with this. Okay, so that takes us really through all of it. But again, this is the description. I wrote it again here, so the incenter of a triangle is the center of its inscribed circle. Okay, the center of the inscribed circle. All right. So if I have triangle like this. That's the in-center. Okay. Equidistant from all three sides. How do I know? Well, the distance, this is the radius. This is the radius. This is the radius. Equidistant from all three sides of the triangle. Okay. Equidistance from all three sides of the triangle, because the definition of a circle says that it's from its center to anywhere along the edges of the circle, which happen to touch the edges of the triangle, are always going to be the same. Right? So that's how you do this. And again, to construct the in-center, it is sufficient to find the intersection of two angle bisectors, since the third angle bisector will also pass through this point. So you could have done another angle bisector. I could have split this angle here, and it would have show you. Over here, I had it. So I could, using color, I could put a line from B through F, and you would see that it would then bisect angle B, and it goes again through the circumcenter, okay, or in-center. Remember, this is also called circumcenter. Cir for circle, right? Or in-center, right? Because it's inside the triangle, okay? All right. So let's see, is there anything else that we want to do from this? We've got just our conclusion. So mark the in-center, and this is where they did it. Mark it. And you've got your point where it belongs. All right, so now that I've told you this, you're going to find different types of triangles. So let's just say if you've got a right triangle, let's see if I can draw a right triangle here. So here's a right triangle. So I'm going to draw a line here, and then I'm going to okay, so the way I did this, I know I've got a right angle right here. So there's my right triangle. And so again, I want something that bisects the, let's call this A, B, and C. So A, B, C. So triangle ABC or BAC. Okay, so I want to bisect this angle. So roughly speaking, just if I was just kind of going to be a guessing man, I bisected angle A roughly, and then bisected angle B, and then so roughly speaking, that should be the center of the circle. Now, if I were to get my compass and assume that that's roughly the center, I'm a little bit off here, so because I was doing this manually, but and so I'm off. Let's see here. Let's erase this. Always do it. So I think I'm going to have to bring just a little bit. Let's see here. And what did I lose here? Lost in that. Okay, so roughly speaking, so I got pretty close to the edges there. So if you take a look at that, roughly speaking, the circumcenter, I guessed it was roughly that point there. So using the circle, I could find it that way, but I can also, find the perpendicular bisector. I'm sorry, not the perpendicular bisector, the angle bisectors. So I can split this up into equal angles. This should be equal angles, and this should be equal angles. So two smaller angles that measure up to angle B, two smaller angles measure up to angle A, two small angles that measure up to angle C that are all, each of those pairs are congruent. All right, so that's a right triangle. Then you can have an obtuse triangle, and I'm just going to sketch these roughly now. So an obtuse triangle is a triangle that has an angle that's greater than 90 degrees. So I'm going to make one that's obviously greater than 90 degrees. So here's an obtuse angle. And so with that one, again, I want it to touch all three sides. Roughly speaking, I would, again, split this like this. This is going to be tougher. Let's see here. Now, to know how to bisect an angle, if you look, the measure of this from here to here is just, I don't know, it's like 4 7/8. So if I go over here, this should be about 4 7/8, and it is, okay? So I'm going to look for the midpoint. So let's call this again ABC. So I want to look for the midpoint of A. And so A is roughly an inch, so about a half inch here. And then the same thing, the side should be roughly the same. It's about an inch, so it's going to be roughly a half inch. So if I do a angle bisector here, it'll go from the vertex over here to the opposite side. Let me see here. And I'm a little bit off. And then I'm going to do it from here to its opposite side, which is roughly about here. And you see that it all centers about here. So I'm a little bit off because you can see that this isn't quite the center. It should be over just a little bit more. It's just because I got my angles off by sketching. But again, I could do a circle. And so I would do a circle around this that would be roughly this radius. So it would, whoops, be, I can't seem to do it. It would fit in here, okay? All right, and then, that's basically how things work within centers. And you just have to know that you're going to have to use the angle bisector, which remember bisects the angle by going from the angle to the midpoint of the opposite side of your triangle. So from A to the midpoint of the opposite side, this should be M1. Over here, this is roughly M2 midpoint. And over here, this is roughly M3. So angle to midpoint, angle to midpoint, angle to midpoint. And then center is where that crosses. That's the circumcenter and or the in-center, if you want to call it that. And again, your triangle is doing it this way, right? So that's basically it. That's how it's done. And so you're going to go to IXL lesson M.5. I will go ahead and write the link for that so people can get into it that way. I'm sorry, not M5, M6. M6 is where you want to go. So you want to do M6. And also, I'm going to do something a little extra for you guys. If you get to 85, I will give you extra credit for the points over 80. Okay, so I know that some of you cannot, for the life of you, get up to that, but if you can get to over 80, so if you get to 81, instead of having 1 extra point, I'll give you 2 extra points. Get up to 85, instead of having 5 extra points, I'll give you 10 extra points, and so on. So, you know, if you get 100 points, you get 20 extra points. You know, those add up and they help you. And I think that will be a good thing to do for the future. So starting as of now, that is what we're going to do. All right, so we're done with this. I'm going to stop the share and I'm also going to stop the recording. Okay. So stop share, stop the recording, and we're done.